Hi. In the description of the video, you will find a link to a folder that contains 4 files. We already use the sales one, we import it into our data model. But if you look to the sales file for the product, we have an ID. So we do not know what is this product as the product details in another file. Cities are from different countries. So if I need to do analysis in a country level, I need a country name for each city, which also in a different file. So we are going to import the 3 other Excel files to the same data model. So we're going to use the get data Excel workbook, or we can directly use the Excel workbook option under home. I'm going to start by the country table. Again, this is an Excel file. This is why we are going to meet the navigator in case we have more than one object. Table is preferred. So right now, actually, the country table and sheet 1 contains the exact same data. But table, because table is a structure reference, it is better to select the table. So I'm going to load the country table, and I will do the same with the product and the manufacturer. The table in the manufacturer file is called brand. So if I point to the manufacturer table, the manufacturer Excel file, I can see that inside this file we have a table called brand. Table has a header, so we can know this is the table because I can see a different color for the first row. Of course, if you don't have a table, you can load the entire sheet, but it is not recommended because sheet is not a structure reference, while table is a structure reference. So I'm going to do the same with the product. Again, if I have table and any other object, it is better to select the table. Now I have 4 different tables. And before we proceed, we need to ask a question here. Instead of having a country in a separate table, I can simply add a column here with the country name. Can I? And another column with the product name and product category, and another column with the manufacturer detail. In short, I can have all my information in one table. Yes, you may have all your data in one table, and we call it a flat schema. Flat schema is a valid schema, but it is not recommended as it can slow the performance of the data model and it can consist error. If you look to this table, it's a well-defined table. It's a very simple, very clear table. I can easily define the project name and the staff member name, but we have a redundancy here. Redundancy means we have a repetition of the data that we can avoid because the project number can be used as a reference for the project name, and the employee number can be used as a reference for the employee name, and the job class can be used as a reference for the hour rate. So we have a dependency here, and this dependency create a redundancy value. I don't need to type the project name if I have the project ID. So project name depends on the project number, employee name, and his job class, and his hour rate depends on his number. So we should break down this flat schema, this one single data sheet, into 4 different tables. If you're interested about this concept, you should read about the normalization factor in database. Anyway, now I have more than one query, one table inside my data model, and I'm going to do some calculation across different tables, and we will end with an error. And this error is very important because we are going to use this error to explain the most important part in data modeling. So I'm going to create three tables. One, I click in blank area. Two, I click in blank area. Three. In the first table, I'm going to add the country from the country table with the total of the price from the sales. We have 2,600,000, and here is the distribution by country. The second table, I will add the product category with the price total, and again we successfully managed to break down the total of 2,600,000 by product category. But when we try to do the same with the manufacturer, when I try to break down the price, of course we cannot have 2,600,000 for each one. What we have here is redundancy error. To successfully create any calculation across more than one table, we should have a valid relationship between them. To see and manage the relationship, we should switch from the report view to the model view. Now I'm going to hide the two panes here. Now it's very clear that we have a relationship between the sales table and the country table. And also we have a relationship between the sales table and the product. This relationship helps to create any calculation across the different tables. So I can sum the price, which is the sales table, by product category, which is the product table. I can sum the price by country. But when we try to sum the price by the manufacturer, we end with a redundancy error because there is no relationship between the sales table and the brand table. Redundancy error is very dangerous because if you have a redundancy error, we do not end with an error. We end with wrong calculation, wrong result. To create a relationship, we need to define the equal field, the equal columns between the table. So if I check the product table, I can see number that identify the manufacturer. So the manufacturer column in the product table consists of numbers. If I go to the brand table, the manufacturer ID consists of numbers. So we need to tell the Power BI that the manufacturer in the product is linked to the manufacturer ID in the brand. This relation based on the number in the manufacturer column in the product and linked to the number in the brand table. So we link number to number. We cannot link number to text. Now when I save, now I have a valid relationship, and if I go back to my report, the numbers now are correct. We successfully managed to break down the 2,600,000 total price by manufacturer. Now we need to explain what we have here. This relationship is one to many. And logically, you should be able to read this relationship in two ways. What this line means here, that every sales transaction, every line, every row in your sales table, each line is linked only to one country, which is logically correct. Because if I go to the sales table, every line here is linked to one city, which means it's linked to only one country. But the same country can have more than one transaction, which is correct. Again, each sales record is linked only to one product, but we can sell the same product many times. Each product is manufactured by one brand, but the same brand can make many products. The most common relationship in any database is one-to-many, and we cannot have many-to-many relationship in data modeling. The problem is if you have many-to-many relationship, the model will accept the relationship, but you may end with the same error of the redundancy. Because if I have two countries with the same name, we have Cairo in Egypt and we have Cairo in the United States. So the relationship now is many to many because the transaction of Cairo can be linked to Egypt or United States. Now, if I do a calculation for United States, it will take all Cairo, regardless it is the Cairo in Egypt or is it the Cairo in United States. So to make it short, we must have at least one in our relationship. Many-to-many relationship cannot be implemented in the physical level. And if you have a many-to relationship, you may end with redundancy error. Relationship schema can be flat if all the table in one sheet, can be a star schema if I have only one fact table and dimension, and it can be snowflake if I have dimension of dimension.